Hello, welcome to part 2 of the Let's Create a Flip Screen game in Godot. If you recall, in part 1, this was the end result. We had a tile map and we could navigate between the screens using the cursor keys, and we could also block movement that was not allowed. In part 2, what we will be doing is creating a player controller and layers in the tile map. What we won't be doing is linking the player controller to the flip screen. What I'm doing now is simply using the cursor keys to switch to the previous and next screen. As you can see, when I move off, we do not flip. That is the exercise of the next lesson. So in the links below, you will get a link to the documentation and the entire download. If you are already familiar with Godot and know about basic player controllers and tile maps, you're quite happy to skip this tutorial and just download the file and have a play. First of all, let's do some housekeeping. Because we want to still be able to flip the screen and control the player, I added some new input bindings. So input map is where you specify the bindings for the controls in Godot. So we use the built-in ones for left, right, up and down here. What we're now going to do is we've added 4 new ones, W, A, S and D, and we've called them debug screen left, right, up and down, and we will then use these to control the page flipping. We will reuse the cursor keys for the player control. If we open up the game, the change made just to use the W, A, S and D was simply as follows. We use the is action just pressed T, which tells us what was pressed, and we check it against W, A, S and D. That was the only code change in the housekeeping. The other change is this was the original sprite sheet, and what I wanted to do, because we're using multiple layers in this new version, is get rid of the black so we have transparency. Okay, and the problem I had was it was saved as a bitmap file and it should have really been a ping. So the file is now a transparent ping file. What this means is in the game we have to manually edit the Cybernoid scene file outside of Godot in our text editor. And this is the file that is generated, and we simply change the resource path to point to the ping, and it used to be bitmap. When we open up Godot, then it will automatically import our image and use the bitmap. But as you can see, we now have a grey background, which we can easily fix as follows. In the project settings, we can go to the general and we find the rendering environment. We can change this background color. It's called the default clear color, and we'll just set it to black. Okay. Now the problem with this is it's actually setting the background color for the editor as well. So what we really want is to allow us to have any color we want for the background, but have a different color for our game, and we will do that in tutorial number 4 when we introduce what is called the canvas layer. The other change that we've made is we have added a new sprite called player, and that is simply a very basic spaceship. There'll be no animation, just this simple image, and that will do us for the game. So in Godot, obviously that image is in the assets folder under sprites, and as you can see our tilemap has the new PNG file. What we want to do now is create our player. So if we add a new empty scene and we want to create another node, because what we want to create is a kinematic body. A kinematic body is simply a node in Godot that has some physics properties, so we can interact with collision shapes and other physics. So the first thing that we want is to add a sprite, and we will use the image of our player for the sprite. As you can see, the yellow warning triangle is telling us that we have no shape defined. So what we'll now do is create a collision shape. And we will add, on the shape, we will add a rectangle. So we can size it using the yellow grab handle, either red grab handles, but the other way is we know the size is going to be 32 by 32, so we set the extent to be 16. Okay. And if you notice, the image is blurred, and that's because I probably didn't set the preset for the texture pipeline. So if we go back to our image and select the import, if we change the preset to 2D pixel and then change the preset to set as default, we can then re-import the image and it will be okay. And every image that we import after that, just to make sure, will now apply the 2D pixel. And all it really does is it turns off filtering, so we don't get any aliasing on our images. So back to our player, we have a sprite and a collision shape. If we want to animate the sprite, we could have used what's called an animated sprite, and that allows us to insert multiple frames. And another way is we could use the sprite as it is, but instead use a sprite sheet and use these properties here to specify the number of frames. We would then need to animate it using a separate node called the animation player. But in our case, we will just be using a single sprite. The next thing that we want to do is we want to set up how our body collides. So when we look at the kinematic body, we'll see here in collision we have two sections, layer and mask. Layer, these are all what's called bit fields and simply numbers 1 to bit 19. Yeah. And each one is simply a 1 or a 0. And they can represent anything you want. So typically you normally use the first bitmap as the player, then you might use subsequent ones for the environment or enemies or hitboxes. Yep. And this first section layer is simply what this collision is on. In other words, what it belongs to. So we will specify the first bit. Now on this mask section, it says the mask means what does it look towards, or in other words, what will it collide with. So if we specify this, then we are saying that our layer is on bitmap 1 and our mask is on bit 2. Okay. And what we'll then do is in our tile map, if we just go to our tile map, we will specify in the collision section that this is on the second one and it looks towards the first one. So in other words, it's the reverse. So the environment will look for the player and the player will look for the environment, and that will then stop our player from falling through the tiles. Okay. Now if you notice that we are specifying the collision layer at the tile map version, we cannot specify the layer names and masks per tile. The only way you can do that is if you create multiple tiles, which we'll be doing in a few minutes time. Now back to the player, what we'll do is we will save this and we will create a new folder and we will call it entities, and in there we'll create a new folder called player and we will call it simply player. So as you can see, we have a new folder called entities. We will also, while we're here, give it an empty script and call it player, and save that. Now, just regarding collision shapes, what's generally a better way of doing things is we just use this collision shape to provide collision with objects to restrict movement. In other words, to, in our case, to block the movement of the player by the environment. When we want to provide hit and hurt boxes, in other words, we want to be able to kill or be killed, the better way is to use a different node called an area 2D, which is simply a collision shape that sends signals when things enter or leave it, and that is the better way. So we separate out hard collisions from in effect soft collisions. Okay. A good example of this is if we had pickups or items that we might want to be able to touch but not necessarily be blocked by, we would use a area 2D. What we'll do now is we will code our very basic player node. What we're going to do is just paste in some values to speed up the process. So first thing we do is we need to set a speed, and we're calling that 125, and we want that to be in effect 125 pixels per second. And next we have what's called a vector, which is just a class that has an x and a y coordinate, and we can do basic vector maths with it, and we'll be using that for our velocity, in other words, direction and speed. We also need to flip the image depending on whether you're pressing left or right, so we're using this fairly badly named variable called direction, where because our sprite by default is facing right, we will use true and false to determine whether we want to flip that sprite or not. Okay, and we also need a pointer to our sprite object. Okay, so first thing you do is we are going to have a set of calls that happen in the physics process. And the physics process is a built-in method for the kinematic body, and it is called at a set time scale of 1/60th of a second, and it's guaranteed to be called. And it passes in a delta, which is the amount of time it took between the last frame and this frame. Because we are using 1/60th, that delta will always be 0.166667, I think. Okay, so what we're going to do with our player is four things. We want to see if the player's pressed any key. We then want to reverse the sprite if we need to. We then want to apply a downward force, and we also want to then actually update the position of the player. So the way the player is going to move is we will move left or right or up in a fixed speed. There'll be no acceleration, and when we leave go of the keys or just press left and right without up, then we will fall at that set speed. So it's all quite simple. So let us code some of those things. So the first thing we want to do is the first function, which is get player input. So if you recall from lesson 1, tutorial 1, we used the method called isActionJustPressed, and it returned a true or a false. Yep. If we cast that to an int, we would in effect get a 0 or a 1. Instead of that, Godot provides a method called get action strength, and that will return a value between 0 and 1. In the case of the keyboard, that will either be a 0 or a 1. So we are simply saying here, if the user's pressed the up cursor, then we want to set our velocity Y component. And we have a negative because in Godot we start in the top left corner of the screen and we move to the right and we move down as a positive. Okay. The next thing we want to do is we want to get whether the user is pressed left or right. And a quick way of doing this without having to code on multiple lines is because get action strength returns a number, we can simply subtract the right cursor from the left cursor and we will get 0, -1 or +1. And that is what we're doing with this sort of tertiary if statement. We are simply saying that if we are pressing a key, then we want to flip the sprite or not flip the sprite. But if we do not press any key, then we're going to leave it alone, because otherwise it will reset to its default view, which is right facing. So if we just leave go of the button and we're facing left, it'll switch back to right. So that's what this line does here. Now, one problem we have with this vector is, in effect, we are moving 1 unit to the right and 1 unit up. But if you press right and up, we will end up with a vector of 1 across and 1 up, which will give us, if you imagine a right angle triangle, we will end up with a value which is greater than 1. So what we need to do is convert that velocity, no matter what the value is, into a unit vector. And we do that through the normalize method. So the next thing that we want to do is we want to update the player sprite. And that is simply done through the flip H property. Okay. So if we look at a sprite, then we have a transform which controls the movement, and we have the offset data which contains the flip. So if we flip the sprite, as you can see, it will flip the image. Now what you can do is use the scale and use a negative number to achieve the same effect, and scale will obviously resize our number. Either will do, but flip is a simpler way. One thing that you should never do though is in your kinematic body change the scale here, because even though it's flipped the image, it also flips every other item, which might be what we want. But if you apply scale, even if it's just to negate the value to a collision shape, then the collision shape can malfunction and you might not get the correct collisions. So stick to flip. That's the easiest way. And that is what this does. And the flip, as we said, is based on the direction which was set in our get player input. Next thing that we want to do is apply gravity. And all we want to do here is, it isn't really gravity, we just want to, even though we're calling it apply gravity, it isn't really gravity. What we are saying is if the velocity on the y-axis is more than 0, in other words, apply gravity is going to apply a downward force to the player if they are not pressing the up key. So if you remember, we negated the y value so that if we press the up key, then our y velocity is -1. Yeah? -1 will mean an upward direction in Godot because 0 is at the top. And what this line is saying is if we didn't press anything, then the velocity is 1, so in other words we will fall by 1. And the next line that we want is to actually move the player. So if you look at the code that we've done, all we're doing is having a velocity with a value of 1 in any direction, whether it's left, right, up, down, or diagonal. We then apply the move and slide method, which is part of the kinematic body, and we move it by the velocity, which is our unit speed of 1 in any direction, multiplied by our speed. And the second parameter is required by move and slide because it needs to know what direction up is. In a simple 2D game like ours, up is always simply up. Now, move and slide only works in the physics frame, so it has to be called from the physics process. And one of the things that it does, it automatically applies delta. So if we reuse the method move and collide, which does a similar thing, it will just hit an object and then return a vector telling us how the collision happened. What move and slide does is it essentially applies move and collide, so it will move the kinematic body, it will collide with something, and then it will slide across its surface. Okay. So we use move and slide just to make things a lot simpler. Now, move and slide will return the resulting velocity, but because we set everything as 0 on every frame, there's no need to do anything else. Okay. So, one last thing before we look at the output from this is we've given every method underscore, and that just simply tells really us as a programmer that this is an internal method and it won't be called outside of this code. So it makes it easy to understand. It's a convention rather than a rule because Godot cannot apply such things like internal and protected and public methods or private methods. We just use it as a convention. So because we have no external dependencies on the player, and because we are not calling getParent anywhere, which in lesson 1 we saw was a bad thing, we can test the player output straight away. And as you can see, everything is moving quite fine. So we are moving down at the same speed as up, we are moving diagonally at the same speed, and we can move everywhere. So we know that our player controller is working perfectly fine. One last thing is we will change the name of our player to player from the default. If you go back to the game scene now, where we have our camera and our map, we can instance our player into the scene. And if we move it to the start position of room 3, which if you recall that is where things start, we can put our player and play the game. Now, when we run the game, we're going to come across a problem, and that is our player is not colliding with any of the tiles. Even though we specified the collision layers and mask, we haven't actually created any collision shapes. In other words, we haven't created any of these collision shapes. So in Godot, when we go to the tile set and we edit a tile, region, as we set up in last lesson, was how we specify each of our tiles. When we go to collision, that is where we specify which of these tiles we want to have collisions. So the easiest way of doing a full tile collision is to turn these two boxes on, which simply snaps the whatever you create to the rectangle. We then select the rectangle tool and we click inside and we create a collision, and we repeat that for every item. So just to speed things up, we already have those tile maps created. So we will overwrite the file. So if we now go into our map, we will see in the tile set that we have collisions for all of the main objects that we want. So now if we run our game, the player now hits our environment. What we want to do now is add some layers to the tile map, so that in this case, instead of going above these items, we want to go behind them. In Godot, when you draw items to the screen, they will be drawn in the order of the scene, so that because the player is last, it will be drawn last. If we move the player to the above the map, then when we run the game, then the player would be behind all of these items. If you want to change the order without having to use this structure of the scene, every item that can be positioned has a value called z-index, and by default everything is 0. So if we specified -1 here, for example, it will be less than the z-index of map, which is 0. Now, one thing to note is when we set these properties here, we are only setting them for the instance in our map. As you can see, this is an instance. So, for example, if we set the z-index to -1 of the player, when we actually go to the real player scene file, you'll see that the z-index is back to 0. And that's because this is the base object, whereas what we modified was a instance, in other words, an instantiation of the player. So when you are doing things in Godot, you need to decide how you want to do it. So in our case, we would more than likely want to apply the Z order to the actual base object. However, if you notice, we only have one map item, so it can only ever all be above or all be below. So to achieve this, what we'll do is we will create layers in our tile sheet. And the way you do that in Godot is you have to create multiple tile maps. So if we go into our tile map and we find our tile map 1, we can then duplicate it to create a second, and this is an identical copy. Now, because tileset is a resource, we are not duplicating all those graphics in the tileset. It is referencing the same thing. So if we modify this tileset in foreground 2, it will be replicated in foreground 1. The way to get around that, if we really do need to have separate tile sets, is we will use a facility called make unique, and that will create a copy of the resource. But the default for everything in Godot, and it's an easy thing to get caught out by, is every resource will be shared. So the way we create layers is we've now got two layers which are identical. To create our layered map, the easiest way is we will copy across certain items from layer 1 into layer 2. The quickest way to do this is we will zoom out to see our map, go to the foreground layer, select everything and delete. We can then go to foreground 1, find the items that we want. For example, this item here, we can remove it from foreground 1 and place it in foreground 2. So as you can see, in foreground 2, we now have our item. Just to speed things up, I have already done this, and I will just copy it across. Okay, so if we now open up the map and zoom out, if we remove foreground 1, we can see I've moved some of the cells from 1 and put them into 2. And if you move 2, then you'll see we have only the items in 1. And we can add as many layers as we want. So obviously what we then do is in foreground 1, we want this to be above the player. So what we will do is set the Z index. So what we want to do is set this foreground 2, which is our items here. We want to make them above the player. So if we set the Z index to be 1, because our player's Z index is 0, and even though we collide with everything, if we set the Z index on the other items to be -1, so they will always be below the player. When we run our game now, we should find that our player is behind everything. And like I said, we aren't flipping the screen, but I will do it manually, and you can see that we in effect have a nice game. One thing that is a problem is, if you notice, we cannot actually get through this hole. Now we set our player to be 32 in our collision box, and our tiles are 32, so it should fit through. So if we do a little bit of debugging and we go to the debug menu and turn on visible collision shapes, when we run our game we will see where all of the collisions are. Now that is sufficient in Godot prior to 3.3, but in version 3.3 it was changed a little bit so that you are now allowed to see collision shapes inside of the editor. But because it's got a big overhead cost, it is off by default. So if we now run the game and get to the screen, so as you can see, we are now seeing all of our collisions, but we can't get through, and everything looks okay. And the problem turns out to be a bug in Godot that is being worked on currently. So to fix it, the only solution that we can do is go to our collision shape and change it to be 15 by 15, so it's just slightly smaller than our screen. And if we go back now, as you can see, we can fit through nicely. And that is the end of this part 2. In part 3 we will link up the player with the camera to allow us to page flip. Thank you.